Borodar, Croeso. Good morning and welcome to this Cardiff University webinar. I'm Ian Weeks and I'm Pro Vice Chancellor of the College of Biomedical and Life Sciences here at Cardiff University. And this is the latest in our new series of webinars under the title Informing Policy, where the university will be providing a space for Cardiff University academics to speak directly with policymakers on a variety of topics where their research expertise can inform policy development. So as well as hearing insights from research and reflections from practitioners at the front line, attendees can also contribute to the discussion through a Q&A session under Chatham House rules to allow for honest and open debate. So today's webinar looks at refining the narrative on river pollution in Wales. And in this session, we're fortunate to have Professor Steve Ormerod from the School of Biosciences at Cardiff University, and he's exploring the latest evidence that shows significant improvements in the biological quality of Welsh and English rivers over the past 3 decades, particularly in urban areas recovering from gross organic pollution. However, important questions are also raised about the interpretation of CSO spill data and highlight emerging pollution challenges from pharmaceuticals and plastics. So our aim is not to downplay concerns about water quality, but to help policymakers prioritise their efforts and focus on the most pressing issues. So once we've heard from Steve, we'll hear some insights initially from Tony Harrington, who has held the position of Director of Environment at Welsh Water since 2011, and many thanks for Tony for attending this also. In this position, he leads the environmental, innovation and science agendas for the business with the objective of providing a safe and sustainable environment for Dual Cymru Welsh Water customers. So with that, if I may, I'd like to go over to you, Steve, for your presentation. Again, many thanks for putting this together and we look forward to it with interest.
Okay, thank you for that. Okay, and I'm beginning the day. I'll know it's 9 o'clock in the morning with these quite lurid, colourful images from 2 different sources. On the right-hand side, from a website called Top of the Poops, which tries to depict England and Wales as a kind of microbiological petri dish, with this rash of CSO spread around England and Wales, which of course we hear quite a lot about in the news. And on the left-hand side, an image from a peer-reviewed journal, The Science of the Total Environment, which we've published a couple of months ago. And these are the areas that I'll be exploring and some others as I go through this seminar this morning. Now, I guess any of us who is in the water business cannot have failed to notice that there is really intense public scrutiny, public concern, public interest in the state of Britain's freshwater environment in general. We see almost on a daily basis headlines like these, thousands of CSO spills, Wales dirty secret, the House of Commons Environmental Audit Committee running an inquiry into water quality in rivers, which I gave evidence to, David Aronovich's briefing room, again, a programme that I participated in looking at river quality issues. This is really a very, very hot topic. And I think what I want to try and do in this evidence-oriented seminar is to explore some tensions between what is the public narrative around river quality, what the evidence tells us about what has been happening, what is happening and what can happen in future. I'm going to look at evidence for actually quite progressive recovery in the quality of urban rivers from the 1990s onwards, but also evidence that there has been a recent slowdown in that rate of recovery. I'm going to examine some of the causes around potential organic, persistent organic pollutants, pharmaceuticals, plastic, phosphorus, and then I'm going to explore some questions that are in my mind around what I'm grappling with in trying to understand the evidence and what we see in the river environment. And I guess it's kind of really interesting if you go back far enough into history, if you had been on the Rhondda Valley in 1990, in the early part of the 19th century, you would have seen something like this one, with very, very intense industrial activity. This is the River Taff, the Rhondda system, where it flows into the Taff. And you would have seen not only colliery waste running into the river, you would have seen phenols and cyanides from coal and coking plants and a whole range of other pollutants entering the river system. And equally, as you look at the makeup of the Welsh valleys, one of the kind of structural issues is that many of the settlements are situated in the valley bottoms, which meant that principal trunk sewers actually passed along the river valley bottom. This one isn't in Wales, this is in London Foot near Halifax, but the same problems occurred in other parts of England and Wales. The industrial past, not only were there problems of leaking trunk sewers, but also underperforming wastewater treatment in large parts of these industrial landscapes. And that persisted actually for quite a long time through the 20th century. So if you, in the 1970s, would have gone into the Welsh river valleys, you would have seen that something like 70% of our rivers here were classified as grossly polluted. And that, again, is echoed in different urban areas across England and Wales. When I came to be a student in 1980, I was recruited by this man, Ron Edwards. What was then the University of Wales Institute of Science and Technology was publishing very extensively on a whole range of sewage-related issues, industrial issues, looking at impacts on the Taff, the Ely, the Ebu, the Sahawi. And you'll see the dates on all of these papers are in the 70s and 80s. So at this stage, we were actually looking at a really seriously polluted urban scenario with really major impacts on our rivers. And my interest on this area has been very much on the organisms, the biodiversity associated with rivers, because they are indicators of the quality of river environment. So organisms integrate short and long-term impacts on river systems, and they're really good barometers of the health of river environments. And incidentally, these organisms are today in the news because they are being celebrated in a set of postage stamps that have been released by the Royal Mail that I, in fact, advised on and helped with. Well, we started to look at the long-term trajectory of rivers now about 10 years ago, and a former PhD student of mine, Ian Vaughan, and I looked at about 200,000 samples from across England and Wales, 20,000 locations over a 20-year period. And we looked at two different dimensions to trends shown by invertebrates. And at this stage, we're looking from 1990 up to about 2008. And it was quite clear that there was a very widespread signal of river recovery. And that was shown in two different ways. One was in the richness of organisms that were present. The other was in this trend from dirty water fauna to clean water organisms as time progressed. That was also supported by data illustrating how various indicators of sanitary pollution have been declining. So things like biochemical oxygen demand going down, ammonia going down, phosphorus in urban areas going down, and nitrite also declining. These are data from England, but Welsh data actually show very, very similar patterns. So here's a set of chemical indicators of organic sanitary wastewater pollution consistent with what we were seeing in biological terms. At around this same time, from the kind of 1980s, 90s onwards, whole range of clean water organisms started to recolonize our urban river landscape. Otters, Atlantic salmon, dippers now breed very widely through the South Wales valleys. Clean water organisms like mayflies, I can take people out to this day and show them large areas of the Taff that have been recolonized by these organisms. Now, not everything is going in a positive direction. So we've got recent evidence that otters are declining, Atlantic salmon are declining very widely, in fact, across their Palearctic range, including Wales. Well, we've continued and followed up these data now, bringing things up to date to 2019, which is as far as our data can go. And these two plots, again, we're looking at the trends in the richness of organisms in this left-hand box plot, trends towards cleaner water organisms on the right-hand plot. But we're now depicting two different things. One is an increase in richness or a trend towards clean water organisms through time in relation to urban land cover. And you'll see several things from these figures. First of all, the recovery in urban rivers has been continuing. There is still a substantial deficit between where urban rivers are and where rural rivers are, both in richness and in clean water organisms. But also you can see in these figures at parts of the agricultural landscape some evidence of a dip and a downturn. And again, these are aggregate patterns from thousands of locations across England and Wales that are telling us that on the one hand, we've got continuing recovery, at least in urban areas, but not everything is positive everywhere. And one of the things we've also seen in these data, we wrote a press release on this paper, which was picked up by the Times and other newspapers, and we particularly wanted to emphasize that there was now evidence of recovery slowing down. So you can see on the right-hand figure again, this is the trend towards clean water organisms, a stasis from about 2010 onwards. The richness pattern probably stabilized earlier than that. This recent uptick is present only in Wales. It wasn't present in our England data. And we've kind of erected a set of possible reasons why this slowdown might be occurring. So sewer overflows, agriculture, climate change, new forms of pollution, such as pharmaceuticals. And I want to step through some of those potential explanations for this slowdown now. Well, we started looking at things like legacy chemicals, PCBs and PBDEs, flame retardant chemicals in river wildlife in the early part of the 1990s. We were some of the first groups to publish congener-specific data, for example, on PCBs. And what you see is that there is still a legacy of these industrial pollutants. So eggs of the dipper in South Wales have some of the highest concentrations of flame retardant chemicals ever measured in songbirds, ever anywhere in the world. And we explicitly looked at the relationship between patterns of diversity, urban land cover, and combinations of these persistent organic pollutants, specifically in the South Wales valleys. And you can see there is a suppression of organism diversity wherever the concentrations of these legacy chemicals are elevated. And these are still, I think, a problem to us. Something else also that we've been really interested in looking into is the occurrence of a whole range of different pharmaceutical agents in rivers in South Wales. But again, this is a general area of concern. In the River Taff, in fact, some of the first ever data from Britain on pharmaceutical concentrations was published by colleagues from the University of South Wales now about 20 years ago. We've got people concerned about things like veterinary chemicals in the river environment. And this, by the way, is my own dog, Leo. I had a student who was particularly interested at looking at two chemicals, fipronils and imidacloprid, that are used in pet flea treatment products in rivers in South Wales. And we designed an investigation where we expected the Roath Brook system in Cardiff to have only these pet flea treatment chemicals that could come from dogs swimming in the river. And we wanted to compare that with the Taff system, where we knew there were other sources of chemicals, in particular from sewage. And what came out of this study absolutely floored us, because what we expected to be the clean water Roath Brook actually had very extensive concentrations of a whole range of different pharmaceutical agents. So these are percentage occurrences of a whole range of different antihistamines, hypertensive treatments, psychiatric medications, with very high concentration or high occurrence also of caffeine which of course is a tracer for these things having a human source. These are percentage occurrences across both the Taff and the Roath Brook. And when we looked at spatial pattern, again, there's a really interesting trend here. So on the right-hand side of the figure, we're looking at the River Taff. On the left-hand side, we're looking at Roath Brook. In the Taff, what we see is a very substantial increase in concentrations downstream of Kilfinnith wastewater treatment work. So there is a kind of expected spatial pattern where a whole range of pharmaceutical agents enter the river. But on the left-hand side in Roath Brook, the point of increase actually marks the point at which the river enters the urban area of Cardiff. You'll see quite interestingly that caffeine is at much higher concentrations in Roath Brook than it is in the Taff. And what we think this pattern represents, in fact, is misconnections of household drains, household sewage, to the surface drainage system instead of the foul sewage system. We're about to expand this work literally over this weekend. I will be out sampling more urban rivers in Cardiff and also rural rivers to look some more at spatial patterns in these pharmaceutical agents. But I think we have to understand much more about the occurrence and effects that these chemicals have. Plastics also has been an area of very significant interest to us. So we know around the world there are about 20 million tons of plastic entering the world's oceans annually. About 80% of it comes from rivers. Substantial parts of this is microplastic. And again, there's some data published some years ago illustrating that if you looked in the benthos, in the bed of urban rivers in the United Kingdom, this is the Irwell system in Manchester. Colleagues Rachel Hurley and others in the University of Manchester measured around 500,000 plastic fragments for every square metre of riverbed in the Irwell. And we alongside this work, we're looking at concentrations of the same chemical, the same kind of plastic agents in river organisms. We asked the question whether there was any possibility that plastics were arising from wastewater treatment works. Was it occurring in invertebrates? Might it be finding its way through to river birds such as the dipper? And we designed an investigation looking upstream and downstream of a range of wastewater treatment works. And we're absolutely staggered that 50% of insects in these rivers were already contaminated by plastic. There was no straightforward relationship with wastewater treatment works. We're still trying to understand exactly why that is. But also we had evidence that not only was 1 in every 2 insects contaminated by plastic, birds like the dipper, which have no choice other than to feed on these insects, are ingesting hundreds of fragments every day. They're feeding something like 5,000 to 8,000 microplastic fragments to their chicks before the chicks fledge. At this stage, we don't know whether there are any effects. And again, we're interested in following up this work, but very clearly what we're seeing here is the contamination of food webs by plastics and also intergenerational transfer of this material between adult birds and their offspring. This is just a problem which is almost certainly bound to intensify. So these are some data from Canadian colleagues looking at the trajectories of plastics entering the world's oceans. By 2020, we had something like 20 million tons entering the world's oceans. Even if we put effective controls in place by 2030, it's likely that those tonnages could already be reaching around 40 to 50 million tons. If we don't get on top of the problem, it could even be 90 million tons. So this is a problem that really could get much, much worse. Well, I did say I would prompt some debate around CSOs, and these are some quite famous distributional data produced on an annual basis by our Rivers Trusts. It's possible to find these data looking at the distribution maps of CSO discharges on an annual basis. What you see is that the areas like the South Wales valleys have most discharges and the longest discharges from CSOs. But the spatial pattern in these data looks pretty similar on an annual basis, which to me implies that this is a structural issue around where CSOs are. And it is worth pointing out that, you know, some of the first papers on the effects of CSOs were published actually on sites in Lancashire in the early 1990s. So this is a problem we've known about for some time. The data on the frequency distribution of spills is extremely interesting. So, you know, the numbers which illustrate that on an aggregate basis, we have something like 66 years of continuous spills of CSOs into Welsh rivers annually. If you disaggregate that by the cumulative frequency of spill duration, something like 80%, just under 80% of CSOs are spilling for less than 10 to 20 days. So you could argue, even though this is a Victorian design, and it's one I think we've got to move away from, those CSOs actually are performing in the way that they were intended to, where they discharge at high flow. Now, of course, we've got another array of CSOs that are performing much, much, much worse and are discharging continually. And the very significant question about these data is what the expense looks like of fixing these problems and how far down this CSO curve we are prepared to invest to give us some benefit in the river environment. The costs of tackling these problems are perpetually increasing. We know we've got to put whole holistic systems in place in urban areas to slow the flow of water entering CSOs, but this is a really, really big area of debate around who pays, what the cost is, what the benefits will deliver to the river environment. And again, this can be followed up by quite interesting data looking at things like phosphorus fluxes into our best rivers in Wales, the special areas of conservation. And we're looking here at, across the Usk, the Wye, the Tavy, the Dee, the Western and Eastern Cleddau, concentrations, fluxes of phosphorus from sewage treatment works, from agriculture, and from intermittent CSO discharges. And you'll see that CSOs, in fact, in these cases, are a much smaller contributor of phosphorus flux than, for example, underperforming wastewater treatment works in rivers such as the Tavy or agriculture in some of these other river environments. And it really is, you know, the agricultural sector I want to wind up by talking a little bit about. We know that there are suspicions about issues with intensive agricultural units and what they do to river environments. And this is now a follow-up. These data are not yet published, but this is a follow-up looking at the spatial pattern in river recovery across England and Wales, looking again at regulatory data from our Environment Agency and Natural Resources Wales. And you'll see that anywhere that's blue on this map are areas that are recovering, dominantly the urban areas, again, gaining richness, gaining clean water organisms. Anywhere that's brown on these maps are areas where there is continued deterioration. And I think you can infer some land use patterns from what you see as you look at these maps. We're still investigating through various statistical models what the most likely drivers of these trends are, but they are, of course, interesting in that they're related to land use. So to wind up then, and just to kind of rehearse a little bit the questions that are in my mind, when we deal with river quality, we are dealing with an issue that has multiple facets. This is not a single one-dimensional problem. I think there is a clear need to accelerate work in some areas that I personally find quite concerning, and that's around pharmaceuticals, what that might mean, for example, for antimicrobial resistance. I think we need to build a clearer case on where we should most invest in infrastructure to give us the biggest gains in quality in the river environment. So, for example, CSOs versus sewage treatment works. Very clearly, we expect some problems, I think, to deepen, and plastics is one of those. And I also think we need actually to, you know, almost to borrow words from our First Minister, constructive action and engagement with the agricultural sector. to try and help obviate some of the problems that are stemming from those areas. So at that point, Ian, Tony, I will bring my presentation to an end and stop sharing and commend that to you.
Okay, thank you very, very much, Steve. That's really, really fantastic data and very thought-provoking commentary on that. I think, to me, it really does illustrate the value of the data analysis here in exactly what we're trying to do in this session, in informing policy, directing, the industries to how best approach these in what are very challenging in times all around. So that's fantastic. Thank you very much. I just wanted to maybe briefly bring Tony in to see if, Tony, you've got any comments or questions on that. And then what we'll do is to open the floor to others on the call. So any initial thoughts, Tony, before we hand over?
Thank you, Ian. If I could just second how interesting and fascinating that presentation was. Really, really, really good, Steve. I had a reflection, actually. You mentioned that the ecology of our rivers had sort of plateaued effectively in terms of the level of improvement over the last 10 years. And I was just reflecting that it's in the last 10, 12 years that water prices, water charges from the company have actually been falling in real terms, or they themselves are plateaued. And investment has been very constrained over that period of time. And one of the things that may be contributing to the plateauing of the water quality improvements might well be the fact that we haven't been investing as much as we originally did when the industry was privatised in the first 2 or 3 of the asset management periods. Now that's going to change. The latest plan for investment from 25 to 30 includes almost £1 billion actually of environmental improvements, as well as more than £2 billion of other investments that we're going to be making in the infrastructure. So I'm pleased to say that the trend of effectively not making the investments, particularly to improve our environment, is now reversing, and we're going to make very significant investments in sewage treatment and in our storm overflows. The other reflection really was around storm overflow improvements, that the graph of the 80% or so, and then looking at the assets that are spilling far too frequently. Fortunately in Wales, and this is a policy related discussion, policy in Wales is very different to policy in England. And I believe policy in Wales is much, much better than that in England. In England, they're just going for spill frequency type constraints everywhere. In Wales, we're looking at the impact of individual assets. So we will look at each and every asset, assess the impact on the environment and specifically the ecology of our rivers. And then we will redesign the hydraulics of those assets so that they don't impact on our rivers. And we think we will get much, much better value for money for our customers by looking at impact and using an evidence-led approach than a one-size-fits-all type policy approach. That brings me on to a question, if I may. Cardiff and Bangor universities have been helping us gather data now at the inlet of our sewage works, now in response to the COVID pandemic originally, but now we're looking at a much broader set of determinants. I was wondering what aspirations you had around using that data to look at what's going on in the sewage system, and or any novel applications of that data perhaps to help us understand the loadings of different chemicals arriving at the sewage treatment process, because those are typical of the sorts of things that will be escaping from the sewage system via storm overflows as well. So I was wondering if you had any thoughts about how we might use that data to get a really good grasp on CSO redesign, or indeed on novel perhaps sewage treatment processes or anything else like that.
So I'll just 2 comments on your comments, Tony, and then I'll answer your question about the WeWash data. So I absolutely agree that the appropriate approach around tackling CSOs should be evidence-based. And I think understanding where impacts are greatest through understanding just exactly what's being discharged, in what volumes, into what circumstances is absolutely critical, because as we know, CSOs are responsible for less than 4% of WFD failures. That I suggest should be informed by looking at things that aren't necessarily regulated appropriately, and pharmaceuticals are one of those things. And we know that in Europe, of course, there is increasing attention being paid to some of these chemicals. And just to comment also on the investment that followed from the urban wastewater treatment in the 1990s was seen as a very significant way of really tackling what at that stage was a really serious problem. And as time has gone on, there has been emphasis on keeping water treatment affordable rather than going through remedial steps to improve things at faster rate, which I think is really interesting. So now to go on to the WeWash project, I'm going to be slightly careful here because my wife actually is very centrally involved with this project, and there is some intellectual property around just what we might do with those data and how the research that it generates could be funded. But Tony, just to say, we are investigating exactly the idea of the quality of the data that are available, the sampling array that we've got access to through, help from Welsh Water, as well as Bangor University and our own samplers. But there are very clearly opportunities to look at the mix of materials that is either coming through the wastewater treatment system or through CSOs. Of course, let's not forget household sewer misconnections, which have a slightly different responsibility pathway by comparison with what you or others are responsible for.
Okay, thanks very much.
Okay, thank you very much.